what if I asked you, would you make a sequence 1 over k if k equals 1, 2, 3? Can you tell me what that sequence would look like? What would the first term be? 1. What would the second term be? 1/2, 1/3, 1/4, if this was to continue. Okay. Alright, so there's lots of different ways that we can do this. I'm going to put some dots after here, okay? Because sometimes we have sequences that go forever, and when they go forever, we call those infinite. And later on, we're going to talk about things that converge or diverge, okay? If these numbers continue to, as they go on, if they continue to get smaller, we would say they converge, okay? But if they continue to get larger, we would say they diverged. Which of these sequences, then, which of these sequences does it look like is going to converge? The last one, right? Yeah. Okay. Good. All right. So then we should review explicit and recursive. Okay. Explicit. There's two different ways we can define sequences. Explicit defined sequence is where I actually put the term number in. So just like this one right here, for the first term I put in 1 to the first. For the second term I put in 2, and so on. Okay, and so if I gave you, and I'm just doing random ones now. I'm not separating into geometric or arithmetic yet. If I define this sequence, so I said a sub k. That's a subscript. You guys remember subscripts? That just means a general term is k squared minus 1, okay? This is not arithmetic or geometric. Then let's write the first 6 terms. All right, so what would the first term be? No, we would start with the first term. That first, if I said first, that is the number 1. Yeah. 0, good. So a sub 1 would be 1 squared minus 1, which would be 0. Very nice. Okay, that's the first term. What's the second term then? Good. So you're actually putting that term number in there. Keep going. Third. No, because we just got 0 and 3. What's the third term? 8. All right. Fourth. Okay, I'm not writing down what I'm doing because I'm getting that you get the pattern, right? You're putting the number in, squaring it, and subtracting 1. The 5th and the 6th. $35. Okay. Here's the nice thing about an explicitly defined sequence. If I said, hey, find the 80th term, it's pretty easy. You just plug in 80. Okay, so it's really easy to find individual terms. You don't even need to know what the previous term is. Okay, so for explicit formulas, they would be good when you don't have all of the terms before it. So that's how we define things explicitly. When you want to define something recursively, that's a little different. What we do for recursively is we define terms by the terms before it. We define terms by the terms before it. And what I mean by that is, typically, it doesn't have to be the term right before. It could be like the term to before it, but we are just saying, hey, this is where we're going to start, and then we're going to move on from there. And so this is how a recursive sequence looks. So I'm going to write b sub 1 equals 3. Tell me what that means. If I said b sub 1 equals 3 in our own first term equals 3, that's all that means. To find b sub n, to find the nth term, that's what that means, we're going to take b sub, this is a subscript, b sub n minus 1 plus 2 for all n greater than 1. And we're assuming that these are integers, okay? So in other words, this is the first term, and it's saying to find the nth term. Isn't n minus 1 before n? So to find the nth term, you take the previous term and add 2. That's all that means. So subscripts are a mathematical way so we don't have to write out like 3 sentences to describe that. Because if I wanted to describe that in sentences, I'd have to say the first term is 3. To find the next term, you take the previous. Subscripts are a notation. They're a shortcut for describing terms. All right, can we write out the first 6 terms of this? This is different. Remember how I plugged in 1, 2, 3, 4, 5, 6? What's the first term here? Good. I told you it. It was 3. What's the second term then? Well, let's see. It says to find the nth term, I take the previous term and add 2. So to find the second term, I should take the first term and add 2. So what should the second term be? 5. So then for the third term, this rule applies. Take the previous term and add 2. So to find the third term, I should take the second term and add 2. So what should the third term be? 7. What about the fourth? 9. The fifth? 11. The sixth? Okay. Now, remember before, up here, if I told you, hey, would you find the 100th term? What would you have to do up here? You'd have to do 100 squared minus 1. You'd need a calculator, but it would take you like 5 seconds, right? What if I told you to find the 100th term here? Crap, you'd have to keep going till you got to 100. So do you see the difference between the two? That's really the point of that.